Hello dear students, I am Padmavati, Senior Chemistry Faculty working with Narayana Educational Institutions. Today I would like to discuss Chemistry JEE Mains paper conducted on 29th of January. Actually this paper we have extracted from the memory of the students. So definitely after the final paper has out, there could be some changes in the options and the pattern of the question asked. So let us see the first question. Which of the following is paramagnetic in nature? So this can be explained on the basis of molecular orbital theory. After distributing the electrons into molecular orbitals, if any one molecular orbital has an unpaired electron, it will show paramagnetic behavior. So let us see the first option, sodium peroxide, where I should distribute in peroxide ion, total 18 electrons are to be distributed. So the increasing order of molecular orbitals for the molecules greater than 14, I mean greater than nitrogen, the order to be followed is sigma 1s, sigma star 1s2, sigma 2s2, sigma star 2s2. If I take z axis as a reference axis, by default it forms sigma molecular bonding molecular orbital. Sigma, you can identify that 2pz2, where pi 2px and pi 2py are of degenerate molecular orbitals. So I am distributing up to here, I have distributed 10 electrons. I am distributing 2 electrons each. I am distributing 2 electrons each. Observe here 14 electrons have been distributed, and then pi star 2px and pi star 2py are degenerate again. The remaining 4 electrons I am distributing 2 and 2 here. So by distributing the electrons into these molecular orbitals, none of the molecular orbital has an unpaired electron, hence it is diamagnetic in nature. So whereas potassium superoxide I should distribute total in superoxide ion 17 electrons. So see from this above electronic configuration, where the last I am left over are 3 electrons, so I am decreasing here by 1 electron, so I am getting 1 unpaired electron. So by default any pi star 2p anti-bonding molecular orbital, because it has 1 unpaired electron, it is paramagnetic and colored in nature. So hence most appropriate answer for this question is option B, KO2. So see the next question. So this is from GOC based on the acidic strength. So identify, they are asking arrange the following phenols, substituted phenols in the increasing order of pKa. Greater the acidic strength, greater is the Ka value, but lower is the pKa value. Actually these are the options some of the students that are saying, but here the correct answer can be based on. So the presence of electron withdrawing groups increases the acidic strength. So observe here, if I am taking 2,4-dinitrophenol, 2,4-dinitrophenol from option D here, there is a presence of 2 strong electron withdrawing groups at ortho and para positions, which are increasing the acidic strength of phenols. So 2,4-dinitrophenol, 4-nitrophenol, para-nitrophenol. So definitely actually might be the correct option can be 4-chlorophenol, 4-chlorophenol, and then phenol, and 2,4,5-trimethylphenol. Methyl groups are electron donating by inductive and hyperconjugation, which are decreasing the acidic strength, So obviously out of the 5 compounds that are given, 2,4-dinitrophenol should be most acidic and 2,4,5-trimethylphenol should be least acidic. So but only my concern is about these 2, phenol and 4-chlorophenol. Even if we refer the pKa values also, as per NCERT, phenol is around pKa 10, and 4-chlorophenol, even though it is minus I and plus M, it is electron withdrawing by inductive effect. Therefore, it should be considered as electron withdrawing, which is increasing acidic strength of phenol slightly greater than phenol. I think could be the correct answer is 4-chlorophenol should be here. By doing that correction, So this option D, we can go with 4-chlorophenol, more acidic than phenol. So let us see the next question. So this is from states of matter, gaseous state. Observe how the van der Waals gas equation can be further, you can say, can be taken the form at low pressures they are asking. If I am writing for 1 mole of a real gas, the van der Waals gas equation, P plus A by V square into V minus B is equal to RT. So at low pressure, I can neglect the volume correction as volumes are high. So I can approximate V minus B to V. I can approximate V minus B to V. So therefore, the corrected equation can be P plus A by V square into V is equal to RT, where by expanding this equation, I can get PV is equal to RT minus A by V. So if I am dividing throughout with RT, PV by RT, which is nothing but compressibility factor, I am dividing throughout with RT. So Z is equal to PVM by RT, compressibility factor. So therefore the compressibility factor Z is equal to 1 minus A by VRT. So this is the form that is taking place. You can say van der Waals gas equation, the compressibility factor at low pressures. So therefore I can go with this Z is equal to 1 minus A by VRT. Let us see the next question. So which is a very simple question, a general question you can consider under the concept of general periodic table also. So they have given, so alkaline earth metal ions Mg plus 2, okay, and calcium plus 2, and alkali metal ions potassium ion, rubidium ion, cesium ion, and asked about order of hydration. So hydration enthalpy is directly, it is proportional to the 1 by size of the ion. Smaller the size of the cation, greater is the, smaller the size of the ion, greater is the hydration enthalpy, because the nuclear force of attraction has to attract the water molecules around it. The process of hydration and hydrolysis are different. Hydrolysis is a chemical phenomenon, whereas hydration is a physical phenomenon, whereby nuclear force of attraction, many water molecules are surrounding the ion. So smaller the, whether it is a cation or anion, smaller the size of the ion, greater is the hydration enthalpy. So obviously greater the positive charge, so smaller is the ion. Alkaline earth metal ions are smaller than the alkali metal ions, and down the group size of the ions increases. So by combining all these factors, so the best order we can go is here Mg plus 2, Mg plus 2 among all these is the smallest ion. Next calcium ion, observe it as here. Down the group of alkali metals size increases, potassium ion greater than, rubidium ion greater than, cesium ion. Hence the correct answer can be option A. Let us see the next question on the screen. Which compound will give both Lassaigne test of nitrogen and halogen? Actually, so they have given a very clear hint. They are asking for nitrogen and halogen. So first, as a simple common sense, we can look for the organic compound containing both nitrogen and halogen, right? Option C and D is not having. So and A, observe it as here, is having both nitrogen and halogen. So the principle involved behind the Lassaigne test is, so the halogen or nitrogen that is present in the organic compound by covalent bond is converted into, you can say, an ionic compound as sodium halide or sodium cyanide, so which can be identified easily. Means the hetero element is coming into the sodium fusion extract, if it is nitrogen in the form of sodium cyanide, if it is chlorine in the form of sodium chloride. So therefore, so you can go with, it's a very simple question to answer. Both nitrogen and chlorine are present. So don't look for directly the compound should be ionic. So it is extracted into the aqueous solution in the form of ionic compound. So it could be here parachloroaniline, option A. So let us see the next question. Number of bridging carbon monoxide carbonyls in, so you can say tungsten and a dinuclear complex of manganese they have given. So if you refer from NCERT under the complexes, the last pages they have given very clearly these structures. It's a mononuclear complexes. So around the tungsten, all you can say 6 carbonyls are octahedrally surrounded, where carbon monoxide is the ligand here. Carbon monoxide is the ligand. Obviously, so this option you can eliminate, right? Because there are no bridging. If it is a binuclear complex, then there can be bridging. It's a single nuclear complex, so therefore there is no bridging. Observe the second one, Mn2CO10. They have given 2 structures, so cobalt, CO2, CO8, and whereas another one, Mn2CO10, where there are no bridging, means common ligands between manganese and manganese. Around each manganese here, 5 carbon monoxide molecules are attached. No common bridging ligands are present here as per the structure given in NCERT also clearly. So therefore there are no common bridging ligands are there between the 2. Whereas in case of CO2, CO8 we can expect 2 bridging carbon monoxide, but here no bridged carbon monoxide are there. So order of bond dissociation enthalpy, this is a direct important concept from the general properties of halogens. So they are asking about fluorine, chlorine, bromine, iodine, their bond dissociation enthalpy. So this is a little bit deviating from our normal expectation. We expect fluorine should be the strongest bond enthalpy, but here the order of bond dissociation energy is Cl2 greater than, Br2 greater than, F2 greater than I2. So in spite of fluorine being more electronegative and small sized atom also, why it is having bond dissociation enthalpy lower than chlorine and bromine? So the best satisfactory answer we can give is here, fluorine being very small sized atom. So between the fluorine and fluorine, observe here. So due to lone pair repulsion, this bond cleaves more easily than chlorine and bromine. So that's why fluorine is having less bond dissociation enthalpy than chlorine and bromine, which is a most important general point to be noted in halogens. So let us see the next question. So which of the following does not liberate hydrogen gas on reaction with dilute acids? Actually, if we go for the electrochemical series, so the metal ions which are having the, you can say, less SRP value than hydrogen we take its standard SRP, SRP value as 0. So negative SRP they can, displace, may or may not liberate hydrogen, displace the hydrogen from mineral acids. So, but which are having more like copper, silver, gold, they cannot displace hydrogen from mineral acids. So here, even though Cr2 plus, Mn2 plus, titanium plus 2, vanadium plus 2, if you refer the SRP values, so given under D block from metal plus 2 to 0 SRP value, even though all of them are negative, particularly Mn plus 2 cannot liberate hydrogen gas from dilute acids because Mn2 plus is a stable oxidation state for manganese. So which is reluctant to undergo further change because manganese in its elementary state it has outermost electronic configuration 4s2 3d5. When I am writing it as Mn plus 2, I should remove the electrons from 4s because effective nuclear charge on 3d is more than 4s. So now Mn plus 2 means 3d5 because of half-filled stable electronic configuration. So it is reluctant to undergo, you can say, readily. So the reduction. So among the comparison Cr2 plus, Mn2 plus, titanium plus 2 and vanadium plus 2, because of the stable D5 half-filled electronic configuration, Mn plus 2 will not liberate the hydrogen from dilute acids. So let us see the next question on the screen. So it's a good theoretical question from electrochemistry on conductance. So observe, when a graph is plotted molar conductance versus square root of concentration. A conceptual question. So KCl, this is a strong electrolyte, acetic acid, a weak electrolyte. So we do the concept D by Huckel-Onsager equation. Molar and equivalent conductances increases with increase in dilution. For strong electrolytes, molar conductance increases with the dilution, okay, due to, you can say, decrease in inter-ionic forces. And they obey the equation, they obey linear relationship. Molar conductance is equal to, which we call it as D by Huckel-Onsager equation, saturated limiting molar conductance minus A square root of C, where A is a constant, depends on the nature of the electrolyte or salt we have taken. So this is how, if I am plotting a graph, molar conductance versus square root of concentration, which is bearing mathematically a relation y is equal to minus mx plus c form, which is a straight line making an intercept with the y-axis but negative slope, which is bearing a linear relationship. So therefore, by extrapolating this line to the y-axis where it is touching the y-axis, I can get to the limiting molar conductance. Means if for a strong electrolyte, if I am increasing the dilution at certain particular temperature, its conductance keeps on increases. So what is the maximum conductance an electrolyte can show at infinite dilution? If you imagine that I am taking that to the infinite dilution, what is the maximum conductance an electrolyte can show at infinite dilution? I can predict it by plotting a graph between molar conductance versus square root of concentration for strong electrolytes. But same thing I cannot predict for weak electrolytes. The reason is this equation is not valid for, you can say, weak electrolytes. For weak electrolytes, if you are increasing the dilution, of course molar conductance is increasing, but exponentially, it is not bearing the linear relationship. So this is the curve like a rectangular hyperbola I am getting. So therefore, by extrapolating it to the y-axis, I cannot predict what is its maximum limiting molar conductance. The weak electrolyte like acetic acid can be shown. So that's why we use Kohlrausch law to find what is its saturated limiting molar conductance. Okay, for weak electrolytes, to calculate what is its maximum limiting molar conductance, we do the application for Kohlrausch law. So let us see the next question. So this is a very good question framed on, you can say, a simple question, of course. A combined package of organic reactions they are asking, all important only, they are not something remoted reactions here. Observe Hofmann degradation. So if you remember, Hofmann degradation is, you can say, an amide in presence of, if I am giving a general representation, a simple amide in presence of bromine under alkaline conditions, it is under the preparation of primary amines, you can say, you are getting, it's a rearrangement reaction through alkyl isocyanate as an intermediate product, which is by hydrolysis is giving a primary amine. So therefore, Hofmann bromamide degradation I can match with you can say option 2. Actually option 2 I have only A and D, so I am eliminating these two. Elimination mechanism also you can observe. So my answer can be, definitely should be by seeing the first option itself between A and D. Clemenson reduction or a Clemenson reaction they are giving. So Clemenson means immediately, because it's a very well known famous named reaction, Clemenson reduction, Wolff-Kishner reduction. Clemenson reduction means zinc amalgam with HCl. Zinc amalgam with HCl, where so the carbonyl group is reduced to, in presence of zinc amalgam with HCl, reduced to CH2. So this is one of the important preparation for alkanes from aldehydes and ketones. So I can match with 3. Okay, that itself gives you the answer as D. Of course, let us see the Cannizzaro reaction. So Cannizzaro reaction is given by the aldehydes without alpha hydrogen in presence of concentrated alkali. So for example, if I am taking formaldehyde, it undergoes disproportionation in presence of concentrated alkali. So I am looking for a concentrated NaOH or KOH. Observe here. So concentrated KOH. So you can get the, so reduced product is alcohol and the oxidized product is carboxylic acid. Of course, because the medium is here, you can observe it as a potassium salt of formate. So Cannizzaro reaction I can go with the concentrated KOH, Riemann reaction, orthoformylation of phenols. So phenols with chloroform and NaOH, it's under electrophilic aromatic substitution where dichlorocarbene is the electrophile generated from chloroform in presence of alkali. You are getting, I can consider this as orthoformylation. Salicylaldehyde is the main product, major product, orthohydroxy benzaldehyde is the major product. So I can match the Riemann reaction with chloroform with NaOH. So more appropriate answer is option D. So let us see the next question. So you are given, observe two steps, zinc amalgam with HCl, Clemmenson reduction, just now we discussed, and lithium aluminum hydride. So lithium aluminum hydride and sodium borohydride are the two most important reducing agents to be so followed here. So you have two functional groups here, a keto and an amide functional group. So just now we discussed, see its importance, Clemmenson reduction, Wolff-Kishner reduction, zinc amalgam with HCl. So zinc amalgam with HCl, Clemmenson reduction reduces C double bond O to CH2. So remove this double bond O group. In place of double bond O, we are giving two hydrogens, right? And it has no action on amide group. So whereas lithium aluminum hydride reduces amides to, you can say, primary amines. So this is replaced by a primary amine. Don't get confused your answer between C and D. Count the number of carbons also here. Observe 1, 2, 3, 4, 5 should be there. So 1, 2, 3, 4, 5 are there in the last option. So don't go your answer immediately by option C. Count the number of carbons also. So your correct answer will be where I am removing the keto group, converting into CH2 and amide group into a primary amine, right? So let us see the next question. So number of millimoles of calcium hydroxide. See how simple questions they have given, but there is a lot of scope if you are in a hurry and in a tensed mood to do the, you can say, wrong calculations. They are asking not moles, millimoles. Number of millimoles of calcium hydroxide in 100 ml of solution given pH equal to 12 they are. So calcium hydroxide is a base. So pH equal to 12 means obviously concentration of H plus is 10 power minus 12. So concentration of OH minus will be 10 power minus 2 because the product of concentration of H plus and concentration of OH minus by default at 25 degrees Celsius is 10 power minus 14, which we consider it as ionic product of water, Kw. So OH minus is 10 power minus 2 means what is the meaning of it? So I have, observe it as, I have 10 power minus 2 moles, 10 power minus 2 moles in 1 liter of aqueous solution, means in 1000 ml, 1 liter in 1000 ml of the solution. But they are asking about the 10 power, millimoles. I am multiplying and dividing with 10 power minus 1, 10 power minus 3 moles is 1 millimole. So means it is nothing but, so I am getting it as, excuse me. So I am getting this as 10 millimoles in 1000 ml, 10 millimoles of OH minus ions. This is what? Concentration of OH minus I am getting, not calcium hydroxide directly. So 10 millimoles of OH minus I am getting in 1000 ml. So they are asking in 100 ml. So therefore obviously I have 1 millimole of OH minus in 1 millimole of OH minus in 100 ml. But observe again, don't be quick in response. Observe again, is it your answer is between 1 or 0.5? They are asking about the calcium hydroxide, not directly OH minus. 1 mole of calcium hydroxide will give you 2 moles of OH minus ions. I got 1 millimole of, you can say, OH minus. So therefore, the number of millimoles of calcium hydroxide should be 0.5. 0.5 millimoles in 100 ml. There is a scope of doing small mistake in this question. So if you think directly as OH minus, you may go for 1 millimole as the answer. So but the correct answer is here 0.5 millimoles of calcium hydroxide can give 1 millimole of OH minus ions in 100 ml. Let us see the next question. So see a very simple question they are asking about. Kf value is given, specific rate constant for forward reaction is 10 cube and specific rate constant for the backward reaction is 10 square is given. Then what is delta G naught? So this is one of the most important relation. Delta G naught is equal to how it is related with equilibrium constant minus RT ln K. So where the equilibrium constant K I can calculate it as it is the ratio between specific rate constant of the forward reaction by specific rate constant of the backward reaction. Kf by Kb means how much it is equal to. So it is equal to 10 cube by 10 square, it is coming out to be 10. And always we do the calculation with respect to base 10, this is logarithm of base E. To convert base E to base 10, I am multiplying with 2.303 RT log of base 10 K. So no need to substitute the R value in all the options, they are keeping the universal gas constant. So in terms of R they are asking you to calculate. So therefore I can write minus 2.303. Okay, I am keeping the R as such. T temperature given is 27,300 Kelvin, whereas log 10 is 1. So obviously you should do an approximate calculation of 230 with 3, you are getting minus 690. R is the answer. So let us see the next question. Which of the following metals is purified by Mons process? So this is from metallurgy. So during the refining of metals, one of the important refining of metals is, you can say, vapor phase refining. There are two vapor phase refining processes we come across in NCERT in metallurgy chapter, that is, you can say, so Mons process and Van Orkel method. So Mons process is exclusively for purification of nickel. So impure nickel, you can say impure nickel with carbon monoxide on slight heating approximately around 60 degrees Celsius, like that, you will get tetracarbonyl nickel in the vapor phase. So I am starting with the impure nickel. Out of the impure nickel, only pure nickel combines with carbon monoxide to form the complex tetracarbonyl nickel 0, in gaseous state. That's why we call this as vapor phase refining. So this is on further slight heating, it easily decomposes back to nickel again and carbon monoxide escapes out. So what is the difference between the last nickel that we got and what I started with is, now this nickel is pure. This is one of the method to purify the nickel, so by Mons process. So let us see the next question. So they are asking which of the following is not odd electron, NO, NO2, NO2 plus ClO2, BrCl3. So maybe the question is not properly framed by the students. So of course observe here, BrCl3, NO, NO2, NO2 plus and ClO2 they are giving. So only exclusively ClO2 is not given. Out of the given species NO, NO2, NO2 plus ClO2 and BrCl3, you have odd electrons in NO, So nitrogen, you can write it as around the nitrogen 2s2, 2p3. Observe 2 electrons forming sigma bond, a pair of electrons and oxygen, right? So you can write of course resonating structures to this. So you are getting an odd electron. Over the nitrogen. This is, you can write it as a 3 electron bond. So hence you can make out as this is an odd electron species. NO2 is also an odd electron species. Whenever nitrogen forms a fourth bond, it will be a dative bond. So observe, it is also an odd electron species, but NO2 plus is not an odd electron species. ClO2 is an odd electron species, again 3 electron bond. BrCl3 is not odd electron species, but exclusively ClO2 is not given. So hence which of the following is not odd electron they are giving. So BrCl3 is not the odd electron. This is odd electron, this is odd electron. Here NO2 plus, even though not odd electron, but ClO2 is containing an odd electron. So hence the answer can be the option A, BrCl3. So let us go to the next question. So this is a direct NCERT based question from chemistry in everyday life. Which of the following compounds used as narrow spectrum antibiotic? But gentamicin I think not mentioned in NCERT. Penicillin and erythromycin are mentioned. Under other classification also, penicillin as a bactericidal, whereas erythromycin as bacteriostatic. Observe gentamicin, penicillin, gentamicin and erythromycin. Narrow spectrum means, so either they act on gram negative or gram positive bacteria, whereas broad spectrum means they will act means against all type of bacteria. But these are all the given penicillin, gentamicin and erythromycin. So they act only on particular kind of bacteria, hence I can go with all of these. So let us see the next question. So this is from environmental chemistry. So they are asking you to select the correct statements. Photochemical smog has high concentration of oxidizing agent. Classical smog has high concentration of oxidizing agent. So classical smog, so smog they have given as per NCERT as two types, reducing smog and oxidizing smog. So whereas observe photochemical smog is an oxidizing smog, whereas reducing smog contains mainly sulfur dioxide, so which is favorable under cool and humid conditions. So therefore photochemical smog containing the oxides of nitrogen has high concentration of oxidizing agent is the correct option. So let us observe in Ostwald's process. So might be there is a small error in making this question. The correct answer can be easily you can identify. In Ostwald's process, actually which is mainly to prepare nitric acid by Ostwald's process, ammonia is getting oxidized, you can say, in presence of air in presence of platinum gas as a catalyst to give nitric oxide. Ammonia plus O2 is giving nitric oxide. Nitric oxide is further oxidized to NO2. NO2 with water is giving mixture of you can say oxyacids HNO2 and HNO3. NO gives brown ring test. So brown ring is here, you can say penta aqua nitrosilium iron 1 sulfate is brown ring, or in a simple way I can also write it as an adduct as FeSO4 and NO. Nitric oxide gives the brown ring. So therefore the correct framing is, if A is getting oxidized to B, A should be nitric oxide and B should be nitrogen dioxide, and which is giving the brown ring is nitric oxide. According to that, just we have to frame that question. I think more appropriate answer will be option A, where A should give the brown ring here, positive brown ring test. Okay, I am going to the next question. Observe. So this is a very general question they are asking about. Which of the following tank used to store hydrogen? So store hydrogen means industrially they are asking about the large scale storage. So not a laboratory storage. Laboratory storage means as metallic hydrides also you can store, which is mentioned in NCERT. But as a large scale storage means, so hydrogen is can be stored under two conditions. So at very low temperatures in the liquid form, if it is to be stored, high cryogenic conditions are to be maintained. Cryogenic conditions means the temperature should be very, very low. I should take the temperature of about -250, which is achieving that temperature is very difficult. So therefore, hydrogen you can say industrially, so that's why very cautious, should be explosive also. They are stored under high pressure. Because you can store this under high pressure either in the gaseous form or in the liquid form under the cryogenic conditions, but maintaining cryogenic conditions means in the liquid hydrogen means you have to take the temperature to very low temperatures. Okay, so more suitable is you can say high pressure tank. So let us see the next question. So this is from boron family 13th group, the compound formed in borax bead test. Okay, that's a direct question, not a remote question from the 13th group. Test of copper sulfate in oxidizing flame. So borax when it is heated, Na2B4O7 10H2 sodium tetraborate. So when it is heated, so first it is losing all water molecules of crystallization, you are getting sodium tetraborate. When it is further heated strongly, you are getting a, so you can say mixture of sodium metaborate and boric anhydride. So under the hot conditions, when this is brought near to the copper sulfate, so copper sulfate under the hot flame, it can say it is dissociate into copper oxide and sulfur trioxide. So this is a transparent glassy mass. When it is brought near to the copper sulfate, which decomposed to copper oxide, with the copper oxide, boric anhydride is forming a adduct CuO-B2O3, which I can write it as copper metaborate, cupric metaborate, which is a blue color bead in the oxidizing flame. So it is a, you can say, so direct question, you can say concept given in NCERT. Okay, so hence I can say copper metaborate, observe it as option A, CuBO2 taken twice. So BO2 minus is a metaborate ion, just like meta-aluminate ion is AlO2 minus, this is a metaborate ion, right? So let us see the next question. So I think these are the questions that are available with us. Okay, so thanks for your patience, hope you have enjoyed. Okay, thank you.